starts with the product area model because you're going to go ahead and solve it using the area model that you've been doing the last several days. And then you can always come back to it if you forget. Trying to the glue stick.
Yeah.
What I want you to do is in your book, I want to check. I want you to go ahead and solve it using the area model that you've been doing the last several days. So think about drawing the boxes. Yeah. Normally I would have you underline, circle on stuff. I'm not going to do that yet because the glue's still drying. I know, I'll have the next class do it before we glue it. See, unfortunately, you get. So how many boxes, I'm seeing Lucas has got it. Think about how many boxes you have to draw for the area model. We nailed this yesterday. I should have done this. I should have had you do this first. What numbers would I circle now that my glue is dry? Miriam? 24 plants. Is there anything else that's important in there as far as the number goes? 67 students. Is 3, we have 3, right? What are there any other things we want to circle? Any other numbers we want to circle? Okay, are there any, what is the question that you want to underline?
How many plants will Mr. Lopez have with all of the students?
Is there an important word that you see in there? Total in each. Very good. So total lets us know, well, yes, he has 67 total students. Each lets us know that each group is exactly the same. Each group is exactly the same. What else? All. Anything else? How many? It's not for 3 science classes, it's for each student. Now, why is each important? Why is that so important? Think about it. What does it tell you? If we say each, what does it let you know? Does he need 24 plants for her and 53 plants for him? 48 for her? Or is it 24 for each person? Okay, so what does that tell you that you can do? You can do multiplication, because what is multiplication? What is multiplication? It's times. What else? I heard somebody say it. Not Repeated addition. Can we add to solve this? Can you add to solve this problem? Yeah. What would you do?
Well, first what I did was I broke it down into the square.
But could you add to solve this problem?
Yes.
Yeah. How would you add to solve this problem? I know you guys already did we jumped to the multiplication, but how would you add to solve the problem?
You would add 24, 67.
We could add 24 plus 24 plus 24 plus 24 plus 24 plus 24 67 times. Would that work?
Yes.
Do you want to do that?
No.
I don't want to do it. So remember, we talked about knowing how to multiply is important because it's faster addition. It's repeated addition. All right, now let's look at how you set up your problem. Yes, ma'am. You know the answer, so how do you set it up? What you draw?
I draw the square with the 24 on top and 67 like next to it.
So I look at your book. You drew 4 boxes, right? Yep. Now, what numbers did you put up top?
20 and then I put 4.
20 and 4.
And I put 60 and I put 7.
Thumbs up, do we agree with that? Okay. Guys, thumbs up and thumbs down. Did somebody do something different? Because that by the end of this, by the time we finish this lesson, that you guys could multiply 1 digit times 3 digits. You did that. You guys proved that you were awesome with that. 2 digits times 2 digits. Using the area model. We have that down. For the most part, every person yesterday demonstrated that they have that down. Now that was using models. Today we want to focus on using equations. So if we're using the model, how do we finish this? Yes, ma'am.
You have to hide the 2 zeros and do 6 times 2 and that equals.
I still see a struggle. Is us make sure that we're lined up, not just all lined up, but neat. It's still errors because we're not writing our numbers neatly. So I want to go ahead and make sure that I write my numbers nice and neat. And we add it up. So what do we have for an answer?
1,608.
1,608.
Yes.
Everybody agree with that?
Yes.
All right. Now, if you feel comfortable with multiplying this way, give me a thumbs up. If you still need help, if you don't feel real comfortable, be honest. I didn't see a thumbs up from everybody. If you feel comfortable with that, I want to see a thumbs up. Okay. I think I have just one person here, and we'll continue to work on that. Now, the next step, guys, is we want to not always have to draw a box model. We don't always want to have to draw this. So the next step is getting to where we use something called, we talked about the distributed property, and it's multiplying your numbers without drawing the picture. So what I want you to do is write down what you just multiplied. 24 times 67. Now when you had that problem up here, what did you do to the 24? Did you write 24 at the top of each box or at the top of the box? What did you do with it? Noel?
I wrote a 20 on the left and then the 4 on the right, and I separated it so I put a line in between the 20 and the 4.
So you broke apart the place values, right? You didn't write 24, you wrote 20 and 4 and 60 and 7, because what is 24? 20 plus 4. You can always put a plus sign right there and a plus sign right there. Well, I want to do the same thing underneath this. $20, because 24 is 20 plus what? 4. I'm sorry, yeah. And 67 is, spell it? 60 plus 7. This is the exact same thing you just did up here. You took 24 and you made it 20 plus 4, right there. And you made 67, 60 plus 7, right there. And then you multiplied it. Well, we're going to do the same thing. We're going to break it apart without the box model, and then we're going to multiply it. And when you multiply, think about what did you do here first? Did it matter what order you multiplied these in? No. Now we want to make sure that we draw that we hit every number. So I want you to draw the arrow just like I did. And then if we cover those up and we focus on the top numbers, after we multiply 20 times 60, what did you do next, Jake?
Hmm?
Hmm?
I just thought that you thought that I was distracted or something.
Okay, we'll make sure we're focused on it. Miriam, what'd you do next?
I multiplied 7 times 6.
Oh, you went down here?
Yeah.
Okay, so what'd you multiply?
7 times 4.
7 times 4?
And then I had a piece.
So that's 28, right? And then what'd you do next?
And then I did 7 times 20 and that was
So you did 7 times 20. And then what was the last thing you did?
60 times 4.
60 times 4. So we had all the same answers. Oh, without having to draw the box. Just a different way. This is often referred to as the FOIL method. And it's just using distributed property, just breaking numbers apart. All you're doing is taking, just like you guys did when you did the area model. $60 times 20, 20 times 60. 60 times 4, 60 times 4. You just have to make sure you hit each one. Now we're gonna practice with this today so that we can get proficient, not having to rely on the area model. So that you guys can not only just use models, you can use an equation to solve this. All right? So when we do our groups today, one group is gonna be over here, working with me, just working on the distributed property. Group in the middle, you guys are gonna be doing I-ready, 45 minutes. Once you have 45 minutes, you can go to reflex. Last group, you guys will be working on your fluency. So I have multiple madness again. Why is it important? You like that? All right, we're gonna use our timers today. What is the goal of multiple madness? Why do we do multiple madness? Oh,
Test our brain.
well, to test your brain, or I like to think about it, to train your brain. Train your brain. Why else we do multiple madness? See if you can be faster with multiplication. So you can be more fluent.
To get better practice for test.
Yeah, well, get better practice for the test.
Beat your time.
Beat your time. Why is it so important? Why do I keep harping on, guys, you need to become fluent. You need to get where you just know your facts. Why is that so important? So you don't have to count on your fingers, okay? And because if you're sitting there counting on your fingers, are you thinking about the question you're trying to solve? No. We want to get where you're so fluent. You're so fluent that your brain's 100% dedicated to solving the problem, not what is 4 times 3. I want you to know. What are we trying to do when we do the 4s again? Beat your time. Get faster. Get faster. Get to know your times tables. And then you do these 5s and do your 6s.